be reminded to be muted if you're unmuted. And if you haven't, do join our Discord through the link. I think it's sent in your email. And if you have any questions, you can open a ticket. Yes. So yeah, the overview will be, I'll be presenting on NumPy, then it will be over to Kaiwan on pandas and matplotlib and C1. Yeah, so what is data analytics? Data analytics is the process of examining data sets in order to find trends and draw conclusions about the information they contain. And so our first section, introduction to NumPy. Like NumPy is like one of the most important and fundamental packages in learning data science. And this library provides you with an array data structure that holds some benefits over Python list, such as being more compact, faster access in reading and writing items, and being more convenient and efficient. Because there's like no type checking when iterating through the objects, and it uses a contiguous memory, so it is much more faster. Yeah, and also because NumPy uses this SIMD vector processing thing, like single instruction, multiple data. So it performs operations over multiple units, and they just have to store like the start and the end of the list so that it is like faster to access, rather for this regular Python list, like it's all over the place. So NumPy has this effective cache utilization, which makes enables it to have less time to look up an object. And for applications, there's like quite a wide range of applications, like mathematics, plotting, for example, in matplotlib, backend, like storing like the JPG files in photography, or machine learning. Yeah, so like we have said that NumPy is mainly more efficient because it has a very good like array. So what is an array? A NumPy array is a grid of values all from the same type and is indexed by a tuple in the form of AB of non-negative integers. The number of dimensions is the rank of the array, and the shape of an array is the tuple of integers giving the size of the array along each dimension. Like for example, a 1D array, this 1D array is like a regular Python list, and a 2D array and a 3D array. Yeah, and the advantage is that if we know that the items in an array are of the same type, it is easy to ascertain the storage size needed for the array, and they can execute vectorized operations too. And in contrast to Python lists, when you usually have to loop through the lists and execute the operations on each element. So it's much faster to use NumPy and you have a cleaner code. Yeah, and there are like these attributes of this array. For example, the data pointer, which is like indicates the memory address of the first byte in the array. And the data type describes the kind of elements that are contained within the array, like integer or like whatever. And the shape indicates the shape of the array, describes the number of bytes that should be skipped in memory to go to the next element. So for example, if your strides are 10, 1, you need to proceed 1 byte to get to the next column and 10 bytes to locate the next row. And I guess the strides thing is quite useless, so you can just ignore that. Okay, so like why do we need to use, like how do we exactly use the NumPy package? Like for example, in a scenario, your boss asks you to get the data of sales, where the sales volume is large, and do like random math operations. Like for example, in this year, how much revenue do you earn and how much do you sell, etc. So like, but loading it into an Excel sheet would be too troublesome because you need to manually select each row and compute the mean type in the functions. So it's like very slow. So how are you gonna do this? So you can either tell your boss you can't do it and resign, or you can use NumPy and pandas and attend this workshop. Okay, so like we can first start by installing NumPy. Yeah, if you're using your BSc, you can go to command prompt and you can like type in pip install NumPy and you enter to install it. And if not, you can, if you're using for the Google Colab, then you don't need to do that. But anyway, also we have also sent you this drive that should be in your email. So inside here is the data sets that what is this? That we will be using for today, and this relevant links thing. So you can go to the relevant links and you open this Colab. Yes, which should be this. And after that, like, because you only have the view version, you need to like save a copy in Drive. So like create a copy. Because if you edit on this version, like your changes won't be saved. Yeah, so you can make a copy into your own Drive. Yeah, and you see the title is like a copy of this. And if you go to your Google Drive, under the Colab notebooks, you can see that it is added here. And we also need to like upload the data sets as well. So you go to this drive and you download it. And after, you just right click and then you download here. And then you go to your Colab and you see this files button. You can just upload this file by selecting this icon here. And you can see, you go to this folder that you have just downloaded, which is in your files. And then you select this. And you open. You click OK. And you can see on the left-hand side panel here, like these folders are uploaded. So yeah, so it's done. Yeah, if you like close this tab and you reopen it again, or you like disconnect and delete runtime, these files will be deleted as well. So you need to like re-upload it again. Yeah, so it's set up now. Yay. And there's like random functions on Google Colab. Like you can go to settings and like you can open the corgi mode and like there will be like cats on top of the bar. Okay. So introduction to NumPy. What is NumPy? You can just read this yourselves, which is essentially what we said just now. Like it has a multi-dimensional array object and can perform like basic statistical operations. And if you want to know more, you can go to this reference link over here for more like information on the functions or like usage of NumPy. Yeah. So to use NumPy, we can first import the NumPy package. So we import NumPy as np. Yeah, run anyway. Yeah, so on Google Colab, once you run the first cell, like the progress will be saved, so you don't have to like run it over and over again. Yeah, and actually you can import NumPy as like any other like random variable that you want, as long as you can reference it easily. Yeah. And a NumPy array can be created by like np.array function. So it's np.array and then you open brackets. It's an open bracket because it's a function, and then you just insert a list into this function. And after you print, you can see that the array is printed out. Yeah. And like what we said just now on the slides, these arrays can be of different dimensions and sizes. So there's the 1D array, 2D array, and the 3D ones. Yeah, so for example, this is a 1D array, and this is a 2D array. Like there's a list within a list. So like there's rows and columns. So it's a 2D array and there's a 3D array. So like you can run these cells on your own to like see what's the printout is like. And you can like manipulate, like change the values of this to print out different stuff. Yeah. And like this thing essentially is like telling you to create like four columns. So 4 columns of ones, and you times 3, which means there's 3 rows. And you times 2, which means there's 2 sets of this. So like it's a 3D array. Yeah, and remember like what we said about the attributes. We can also get the attributes like dimensions, say shapes, types, and size from these functions over here, like a.dimensions. So it's a 3D array, so it will output 3. And get the shape is 2 by 3 by 4. Yeah, and get the type is an integer because it's all like numbers, right? It's a 1, 1, 1, 1, 1. So it's an integer. And the size is dot size, which means there's 24 elements here. 4 times 3 times 2. Yeah. And the item size, which is like the number of bytes for one element in the array. So for them to store one of this one element over here, they need 8 bytes. Yeah, so like please don't confuse these two functions. Okay, so after we create the array, we can like access them, right? We need to access the elements inside the array. So elements can be accessed by indexing and slicing like a usual list. So we create the array here, 1, 2, 3, whatever. And we can print the first element. Like Python is 0 indexed. So like the first element index is 0 and the second element is 1. So the index is 0, 1, 2, 3, 4, 5, 6. Yeah, so it starts from 0 and not 1. So if you want to get the first element in the list, its index is 0. Yeah, so if you print this, it will get like 1, which is the first element. And you can also use string slice, the slicing here, which is the start and the colon and the end. So the start is 1, and because it's the first index, and because it's 0 index, the first element would be this, which is this 2 here. And the third element, the element with the third index is 5. So, but like you will end before the last element. So it will end before the 5. So the last element would be 3. So it starts from 2 and it ends at 3. So it will print out like 2, 3. Yeah. And we can also get a specific element for 2D arrays. So this is 2D arrays. So this array is like 1, 2, 3, 4, 5, 6. And we can get like the element in the second row, which is this, and the third number, which is 6. Yeah, so you like always plus 1 to the index over here because it's 0 index. Yeah, so it will print out 6. And you can get a specific row, which is like 0, which means like the first row, and a comma and a colon, which means like getting everything inside this row. So you get 1, 2, 3. You can also get a specific column. So a column means like getting everything right. So, and it's a 2, so you get the third column. So you get 3 and 6. Yeah. If you want to change the elements inside this array, you can also use this, like changing the second row's third element. So if you change the 90, change this 6 to a 90, and you print, it will print out 90. Yeah, so you can see that it is like changed. And we can also like have this indexing on the 3D arrays. Yeah, so it's like the same thing over here as the 2Ds and the 1D one. And you can like change these values to like explore more of it on yourselves. Oh no. Apparently index 2 is out of range because there's only like 2 rows. Okay, So anyway, we can also like replace elements within C. So we replace like the rows with 1, 1, 1. You can see that the first row of each depth is changed from like 300, 233 to 111 respectively. Yeah. So for a recap of what we just covered just now, we can import NumPy as NP and use np.array object to create arrays. And we can also get the attributes of the array. And to access elements, we can use indexing and slicing. So it is the start index and the end and the last index, but the output will be like one element before the end index that you inputted here. Yeah. And to initialize arrays, we can use these following methods as well. For example, we want to create this constant arrays of zeros. So we want an array filled with zeros. We can just call np.zeros. And the number of elements that you want, say for example, like 3, you can see it outputs an array of 3 zeros over here. And like some of the real life applications, like for example, you want to create a leaderboard for like some challenge or whatever, then everyone's points will be stored inside an array, and like each of the points will be starting from 0. So you initialize it as 0. If you want to initialize it as ones, you just call np.ones and the number of elements that you want inside these brackets. And if you want an empty array, you just call np.empty. Yeah. You can also have an array filled with a range of elements. So for example, we can call np.arrange with no space in between. And then you put in the number of elements that you want. So because it is 0 index, right? So it will start from 0, 1, 2, 3. So a total of 4 elements as what you specified here. You can also have this more parameters. The first number, first element inserted, and the last number and the step size. So for this array, it will start from 2, and every time it will go to the next element by adding 2. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. And then it will stop before 9. So you get this 2, 4, 6, 8 array here. You can also have this dot full function, which takes in the dimension and the value. So like 5, so there's 5 elements, which means it's a 1D array. And then each element inside here will be of the value 10. So it's 5 elements, and each element is 10. So it will output array with like 10, 10, 10, 10, 10. You can also use np.full-like, which is also a function kind of similar to np.full, which like mimics the shape of an earlier array. Like so earlier we have this array C, which is this here. You can see like it's a 3 by 3 by 2 one. So if we call this C and pass it into this full-like function, we see that the shape, I think I didn't run this. The shape of this new array will be the same, exactly the same as C. And then the values inside will be replaced by this second parameter that you pass through, which is 4. Moving on, we can also have a random number inside this array. So for example, you want an array with 8 elements and of like generate random numbers. So you call np.random. The first random means like the package. inside this NumPy. And the second random means like the function name. So .random brackets 8. Maybe I want like 8 random integers. So it will output this array here with 8 random integers. And the default, it will be from 0 to 1. So you can see it's all like decimals. And if you want to like customize the low and the high, you can use can pass this. Low equals to 1 and the high is 10. So the range of your array will be from 1 to 100. And the size will be 10, so that means there is 10 elements inside the array. Yeah. And you see it will generate like 10 random numbers. You can also use np.linspace to generate like evenly spaced points. So this is the start, this is the end, and the 5 is the number of elements. So you start from -1, you end at 1, and you want to generate 5 evenly spaced points from -1 to 1. So it'll be like -1, -0.5, 0, 0.5, 1. Yeah. And you can also experiment with other values, like generating 7 evenly spaced points from 3 to 4. So it'll be like this weird decimals thing over here. Okay. And you can also use like matrix in NumPy. We can create an identity matrix using np.identity. And 5 just means it's a 5 by 5 matrix. So it will output the 5 by 5 identity matrix. And we can also like repeat elements. So for example, X is this 2D array here. And you want to create a new array called Y. And you want to like repeat the elements in X. So it's like .repeat, and you pass in the parameters, which is the array that you want to like reference, and the number of repeats and the axis. So for example, here the number of repeats is 3. So you repeat each element 3 times. So it becomes 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. And the axis is 1, which means like you will repeat it like within the rows. So you can see like within each row, the elements are repeated. If you change this axis like to 0, you can see that it is repeated like over these columns. Yeah, so you can like change these values to experiment. Like if you change this value to a 2, it should give you an error because X is a 2D matrix and it only have 2 dimensions or 2 axes, which is 0 and 1. So like it is out of range. Yeah. We can also insert or delete elements in an array using the methods similar to list. However, using the NumPy insert array positional index, like a new array is created instead of modifying the original array. And we can update the array via an assignment statement. Yeah, so basically like we have this array called R, and it's just an array with random integers inside. And you want to insert a new integer at the second position here, and the value to be 5. So you can see it is inserted over here. And like if you just call this, if you just print this, like nothing will happen to the R. The R will just stay the same as this array. So you need to like assign the new array to the original variable. So R will be updated to include this 5 new elements over here. And in higher dimensional arrays, you need to insert an element of the same dimension. So for example, A is like 11, 12, 13, 14, a 2 by 2 array of this. and you want to insert like 5, this row of 5 over here, you can dot insert, you reference A, and you reference like 1, which is like the first row, because it's 0 index. So this is the 0th row. And you want to insert this 5 at the first row. So this 11, 12 is the 0th row, and the 5, 5 is the first row. So we insert the 5 here, and axis 0. You can also insert by like columns by changing the axis to 1. You can change it yourself to see the results. Yeah. And similarly, a new array is created when using the .delete function. So we can delete the elements inside the array as well. The same thing as what we did just now with insert. So it's array, positional index, and the axis. We delete from this array A over here. We delete the first step over here, and then set axis to 0, and we will get this. So you can like change this to 0 or 1 or 2 to see like the effects. And moving on to the next section, we have this shallow versus deep copy over here. Like we introduced slicing just now, which is this like slicing thing over here, the colons and the commas. So like slicing does not modify the original array. The newly created array makes shallow copies of the original elements. That means it copies the elements references, but not the objects they point to. So like, for example, you have an array called X. It is like this 11, 12, 13, 14 over here. And you want to create a copy of X. If you just like use the equals function, equals sign, like you can see it copies, right? And then it works like perfectly. So if you want to print Y, you can see that Y is just the same as X. But if you want to like change the value of one element in Y, say like this 12, you want to change it to 0. Like, of course you can, right? So you can see here, this 12 is changed to 0. But because Y is equals to X, so that this element inside X will be changed as well. So X is originally 11, 12, 13, 14. It is also changed to 11, 0, 13, 14. Like, although we only changed the element in Y, because like this is a shallow copy. So like Y copies like the address of X. So essentially like they are pointing to the same like memory data, like they just have different names. So changing Y will change X as well, which is something that like we don't want, because like we want to avoid confusions, right? Like for example, we want to save one copy over here as backup, then we manipulate the other copy. So to avoid confusion, we need to have like a deep copy. So we use .copy method. So we create a new array called A, and we initialize it to be the same as X. So if we print A, you can see that, oh, because we changed X just now, right, to 11, 0, 13, 14. A is just the same as X. And if you change the first element in A to 1, you can see that it is the 11 is changed to 1. A is changed, but X is not changed. X is still this 11, 0, 13, 14 over here, which is good because we want to avoid confusion. Okay, so like a summary of this part. To initialize array, we can have a one-stop function to initialize it by using the .zeros, .ones, and .empty functions, etc. And we can also, oh, sorry, my PowerPoint is dying. Yeah, and we can also have this random packages to import random numbers and to insert and delete the specific index elements that we want. Okay, so moving on to the next section, operations. NumPy arrays support quick array operations, which can be like very conveniently implemented. So say we have this array A, which is 1, 2, 3, 4. Like if you want to use Python, if you want to like multiply each array inside here by like 2 or something, and to use Python, it's like very long. You need to do like use the for loop, the if loops, and whatever. But with NumPy, you can just like a plus 2. You can use all these math operators like plus, minus, times, divide. So you can a plus 2, which means to add every element inside this array by 2. So 1 plus 2 is 3, 2 plus 2 is 4, and so on. Yeah, so it's very quick and convenient. And yeah, you can like power it, square it, so 1, 4, 9, 14, and like do weird stuff like cosine, np.cosine. Yeah. And when we have two lists, so we have the first list and the second list, they are like 1, 2, 3, and 4, 5, 6 respectively. And you want to add them element wise. So you want to add like 1 plus 4, 2 plus 5, 3 plus 6. And in regular Python, it is very, very tedious because you need to use like this for loop for I in range, blah, blah, blah. And then you need to plus this element and then you output, right? So like if the list is like very long or it has a very large volume, then you need to like spend a lot of time waiting for this Python to run it. So you can use NumPy to just like array 1 plus array 2. So you can just add them together. And you can see the output is indeed like addition. So it becomes like 1 plus 2 is 3, 2 plus 3 is 5, and so on. Yeah, so it's like much faster than regular Python. Yeah, you can also do this math operations as well. So plus, minus, times, divide, or power, remainder, whatever. There's also the Boolean operations. So which are like, I think you learned this in this morning in the Intro to Python workshop, like true or false. So we can check if array 1 is larger than array 2. So for the first element, array 1, it is smaller than array 2, so it's false. And for the last element, 21 is greater than 9, so it's true. Yeah, so it's like very convenient. There's also this aggregate functions like statistic stuff, np.sum, the sum of the values inside this array, the maximum, minimum, median, standard deviation, the index of the maximum element, and index of the minimum element. Yeah, so you can just like explore it yourselves. All right, like if you want to print like say the sum, print the sum of array 1, because like you have so many functions here, you need to like put at the start, print it. Yeah, if not, it will just output like the last function's output because it will get like overwritten. And before we say that, we can create an identity matrix. So here we can also multiply these matrices. So for example, we have this matrix A and the matrix B. You can use .matmul A comma B. So you want to multiply A and B. So you can get this. Yeah, so next time you're doing like your math homework or something with matrices, you can use NumPy to check your answers. We can also like concatenate additional data to your existing list. Concatenation refers to adding data to an array along any existing axis, such as like adding this columns in a 2D array, or like adding these rows. Yeah, so we can use like this hstack or vstack functions. So hstack, you can add more columns to the existing data set. So it will becomes this, and vstack, it will just stack vertically by adding more rows, so it becomes this. Yes, and like this is essentially telling you, like, for example, you want to add A and C together. Like obviously C needs to have the same number of rows as A, right? Like both of them have 3 rows. Like if not, if C have like 4 rows, then it's unable to add, because it's like unable to form like another like new list. So you need to have like the same number of rows for both A and C. Yeah. And like, for example, your C is a 6x1 matrix, and you want to reshape it into like a 3x2 matrix to like enable it to like stack together with A. So you can use the reshape function. So for example, you have this X over here, which is a 1D array, and then you want to reshape it into a 2D array. So you can just reshape it into the shape, and it will output as the shape that you have like instructed it to. And then we can perform this vstack as an example. So X is 3, 5, 7, 1, 2, 3. So like X is, for example, is this first part of the stack over here, and then we can add this Y together. So you just use np.vstack X, Y. And you can see that it is stacked together. And you just have to note that they have to be the same size along all but the first axis, which is essentially what we said just now, right? So like to stack A and B together, they need to have the same number of columns, 4 columns each. Yeah, so here both X and Y, they have 3 columns each. You can also use .where to select the specific rows with the specific data. So .where, then the condition array, and the -1 means like for those elements that does not satisfy the condition, you replace it with -1. So for example, like our X array is this here. You can check if every element is greater than 2. So 3 is greater than 2, then good, we can keep it. But this 1 is not greater than 2, so we replace it with -1. Then you can see it is replaced. Yeah, so it's like quick and efficient. So a summary of today's stuff, we have covered like various functions for various reasons to like, for example, create an array, initialize an array, access these elements, have this indexing and slicing, and like concatenating arrays and stuff. Yeah, you can refer to the slides that we have sent in this relevant links, this PowerPoint slides over here, for the summary of the various functions that we covered today. Here. Yeah, so you can just take this as like a cheat sheet to refer to it if you want. So congrats, we have finished the NumPy part of this workshop. So let's go through the exercises. They are quite short, so it should be quite intuitive. So how do we add these two arrays? We just create a new array, say it's C and you A plus B, and you print C. And we added 1 plus 10 is 11, 2 plus 11 is 3 is 13, and so on. Okay. To create an identity matrix, and use the np.identity here 4 by 4, so you pass in 4, and then you print it. So it will be 4 by 4 identity matrix. Converting a 1D array to a 3D array. So you can like print A to see how it goes, how it looks like. So it is like an array from 0, 1, 2, 3, all the way to 26. So to convert a 1D array to a 3D array, we use reshape. You reshape into like a 3D array. 3, 3, 3. So it would be a 3 by 3 by 3 array. And it's a 3D array. If you want to print the shape, it'll be 3, 3, 3, and it's indeed a 3D array. Yeah. The fourth one, convert all of the elements in an array from float to integer. Like we have seen just now, like you can like use dot d type or something to get the type. So we can see this type is a float. A float is like decimal, so it's 2.5, so it's like a decimal, right? And so it's a float. If you want to convert it to integer, you can new array equals to a.s type. Then int integer, and you print b, and see that all of the elements is integer and it's like rounded down to this integer. Given two NumPy arrays as matrices, output the result of multiplying the two matrices as a NumPy array. Yeah. So you can use this C equals to P dot lemma A B C. Yeah. And it's like multiplied. And another way to do this is you use C equals to A at B. You can replace like dot matplotlib with A at B with the at, which also means like multiplying the matrices. Yeah, so you can see that it works as well. The next question, output array element indexes such as the array elements appear in descending order. Create an array like A. Then you use np.argsort as this array here. And print it. Oh no, it is not sorted. Oh no, something happened. What happened? Oh no. So it's not sorted and it doesn't work. So let's delete this question. Okay, now it works. And for our exercise, we have this data set manipulation. So we just like run this first file, and this file is the file that we imported just now. Or oh no, it's somewhere here. And then we use the .open to like open this file. So just run the first cell. And the first is to like select and print all rows from the price each column. So like you can from your downloads, you can open this like Excel over here. And you can see like inspect this, the columns stuff. Then you're supposed to select and print all rows from the price each column. So like the price each column is this column, right? The third column. So you convert it to an array, and the prices, you create a new array, comma 2. So like you're selecting everything inside the third column. And because it's 0 index, so the index is 2, right? So just 2 and print it. Yeah. And you can see like it's 95.7, 81.35, and it corresponds to the values here. Okay, the next one creates an array of the first 100 quantity with even indices from the price each column. So like from the same column, we like take out all the stuff inside this column with even indices. So like 2, 4, 6, 8 rows. So we just do this and see if it works. How it works. So you can see that it's 95.7, which is the second row, 94.74, the fourth row, and 100, which is the sixth row, and so on. Yeah, so like this is part of the list indexing that we just learned just now. So from the second column, which is this price each column, we start from the 0th row, the first row. So you can put a 0 here, but it's the same. Like you can just omit 0. And then because you want the first 100, but with even indices, so it will stop at like 201, because like 200 divided by 2 is 100. And then so it's the start and the stop and the step size. So like from 0, it will increase each time by 2. So like 0, 2, 4, 6, 8 rows. So in this way you can ensure that it is the even indices. Okay, next question. Select and print all rows from the price each and quantity ordered column as one array. So you inspect this Excel sheet. You see the quantity ordered. Oh, okay, it's here. It's like the second column. Yeah. So you just array 1, 2, 3. So to select the columns, you want to select this column and this column. So the index of the quantity ordered column is 1, and the index of the price each column is 2. So you select 1 to 2, and because like it will stop before the last parameter over here. So you just put 1, 2, 3. And for the rows, you want to select all rows, so you put this colon here. Yeah, and you can see it's like outputted 30, 95.7, which corresponds with the values here. Okay, so that's it for NumPy. Bye, guys.
Okay, hi guys. I will be doing the next two portions, which is introduction to pandas and introduction to matplotlib. Okay, so now try to clear NumPy from your brain and try to focus on the next portion, which is about pandas. Yes, the animal. So what is pandas? It's a library which allows data analysis and manipulations. And it's very powerful in data cleaning and also visualizing. And the main concept of pandas revolves around a table known as data frame, which I'll tell you more about later. So why do we use pandas? Well, it's more flexible and scalable compared to alternatives such as Excel. Or for example, an Excel sheet cannot load more than 1 million rows. So if you want to load more than 1 million rows to analyze the data, you need to use pandas. There are many applications of pandas. First is plotting, which is matplotlib, and you'll learn more about this later. The second is data transformation, which is data cleaning and pre-processing data. And the third one is machine learning, which is data exploration. And you don't need to care about these for now. These are just the applications. Okay, so to use pandas, you have to first install it, right? So this is how you install it. Use pip install pandas, and it's built into your Google Colab. So you can just import pandas. So earlier before I mentioned that there are a few key portions of pandas, and a series is one of them. So the core unit of the pandas package is something called a series, which is a one-dimensional labeled array that can hold any type of data. So imagine a column in Excel. You'll have your index in your column, and then your values in your column. And this is what a pandas series is. And here's a visualization of a pandas series. You have your index, which is 0, 1, 2, and 3. And you have your data, which is your values that you want to input into your series, which is Mark, Justin, John, and Vicky. Okay, so imagine a pandas series sort of as like a column in Excel with your index, which is how you access your data. So how do you make a series? You can use this very good function called pd.series. And now we'll move on to the coding part. So we'll move on to the Google Colab. To import pandas so that we can use it in our Python, we import pandas as pd. So this is just a short form of pandas. So this text is what I just talked about just now. A pandas series is a one-dimensional labeled array that can hold data of any data type and is similar to a column in Excel. You can create a pandas series from many ways, including from a Python list, a NumPy array, which is covered just now, a dictionary, or a scalar value. And if you don't know what these are, it's okay. This is how you create a series from a Python list. So this is a Python list, which I hope that you guys know what a Python list is. People is a Python list. And to convert this Python list into this series, all you need to do is use this pd.series function and throw your Python list inside this function. And it'll output your pandas series. So as you can see here, this is your series. So 0, 1, 2, 3 is your index, and John, James, Jamal, and Jack will be your values. But what if I don't want my index to be 0, 1, 2, or 3? Because that's kind of like meaningless, right? 0, 1, 2, 3, and we want to add more meaning into the index. So to add a specific index, you can use the argument called index. So instead of just pd.series bracket people, you put pd.series bracket people, comma, index equals to, and then you can put another Python list inside here to say what you want your index to be. So as you can see from here, our index is red, blue, green, and yellow. Red, blue, green, and yellow. And our values remain the same. Yeah? You can also create a pandas series from a dictionary. So I'll just skip over this for now because I don't think much of you know what a dictionary is, but a dictionary is something with a key and value pair, similar to a series, but you don't need to know that for now. So we just move on. And here's an exercise for you to try out. So in your Colab right now, I want you to create a series containing 5 countries and their capitals. So the output will look like country 1, capital 1, country 2, capital 2, and so on and so forth. So I want you guys to do this now, and I'll give you like 2 minutes to do so. Right. So I'll go through this exercise now of how to create a series containing 5 countries and their capitals. This is a sample code. So what I did here was I used a dictionary, but you can also use a Python list and the index argument to do this exercise. So how I did this exercise was I created a dictionary, Singapore, France, Paris, Japan, Tokyo, Australia to Canberra, China to Beijing. And then I used pd.series and I threw the Python dictionary inside this function, and then it'll give me a nice little series. So as you can see, we have a very nice series where this is the index. The first column is the index. Singapore, France, Japan, Australia, and China. And the values are Singapore, Paris, Tokyo, Canberra, and Beijing. And I hope that you have successfully done this exercise. And if you have any troubles, you can open up a ticket in Discord. Okay? Now I'll move on. So you can add 2 series together using append. This in here, you put your existing series. So this is the series that we're going to append another series on top of. Series.append, another series, Jack, Jason, and Jerome. And you can assign their index. And here's how you can append 2 series together using .append. We'll skip this exercise. And now moving on, how do I get values from my series? Because like you've already made a series, but now how do you get the values from your series that you've just created? Well, there are 2 functions that you can use to access a series, .lock and .ilog. Okay, so here we have an example of a series. You can see that the index is row 1, row 2, row 3, and row 4. And the values are A, B, C, and D. And what .lock means that it finds the index, which has a value of row 1, and it returns you the value. So if you run this line of code, series.lock row 1, what you get is this value, A. But we also have .ilog. And what does this I stand for? It stands for integer location. So if you are going to number these rows, you number it 0, 1, 2, and 3, because in Python, things are 0 indexed. So this would be like the 0th row, the first row, second row, and third row. And this is what ilog is used to do. If you .ilog the 0th row, you'll get the 0 index row, which is this row. And if you put 1 in here, you'll get B. If you put 2 in here, you get C, and so on and so forth. So when you run this line of code, the 0th row, 0, 1, 2, 3, you get the value of A. Yep, so this is what I roughly covered just now. So if we try to access using this series here earlier on, we get the 0th row, which is this row. And what's the value here? The value is John, and so we get John. As for .lock, this is just the index name instead of the row position. So when you .lock, blue, let me change this to give me a moment. Yep, when you .lock black, what you get what you get is you're trying to access this row, which has the value of Jerome because you get the index of black. Then you get the value of Jerome. And as you can see, you get Jerome from here. So why do we use .ilog instead of just using square brackets without the .ilog or .log? It's because it's a bit confusing to use and you're not recommended to use it. This is because if your index is an integer, sometimes it can get a bit confusing. So just try not to use this notation. So remember to use .log or .ilog with a square brackets if you want to index any value in the series. So ignore this for now. And here's a simple exercise for you to do. So using what you have learned about .ilog and .log, try to get the 5th and 6th elements of the appended country and continent series that you have made in your exercise earlier. So I'll give you guys like 1 or 2 minutes to try it out. Okay, yeah. So time for the answers. So this should be a pretty simple exercise. To get the 5th and 6th elements, you can simply do an ilog. So to get the 5th element, you can do the series name .ilog5. And to get the 6th element, you can do the series name .ilog6. Okay? We'll skip this part. And on to the next section. So if you didn't know, pandas is actually built on top of NumPy. So you have NumPy, then pandas is stacked on top of it. Because you can use various NumPy functions in pandas. So as you can see here, you can sum up all the values in a series using a NumPy function. Okay? We'll skip over this exercise, but you can try it out in your free time. It's just using a NumPy function. And we'll move on to the next part, which is a very important portion. So you've heard about series, right? Series is like your column in Excel. So you have your series name, you have your series index, you have a series values. And what happens when you add 2 series together? You get a data frame. And a data frame is actually the most important thing in pandas, which you work with very, very often. And what a data frame is basically is a table. So this is a data frame. And you can see that it looks like a table, right? There's your series name for each series. So the series is a column. The series is apples. This is the oranges series. It has your index, which is 0, and your values. So it's basically just like a table. A data frame is like a table. And how do you make a data frame? Well, one way is to use the pd.dataframe function, and then you input your data into here. And another very helpful way is loading data from files. So let's say you have a lot of data that your boss gave you, but it's in the form of like an Excel file or like a CSV file because there's like so much values. So you can't possibly like manually type that all out in Python. So pandas is a very useful function for you to read and load the data from these files. Yep, this is what I covered just now. And if you're still a bit confused about the specific syntax of this function, you can click on this link to explore more. So currently you're just going to explore those very simple functions. Okay, so in here we use the .dataframe function to create a data frame. This is the first row because you see like 1, 2, 3. And then you put a comma, and then you go on to the second row values, which is 4, 5, 6, right? So each square bracket will be 1 row. Instead of 1 column, it will be 1 row. And you can assign an index for each row. So you can assign the index 1, 2. Okay? And you can see that there are 3 columns, and you can also assign these column names using this syntax or argument. And this might be a bit confusing for you, but you don't need to memorize all the syntax for now. You'll be able to familiarize yourself with the syntax after you use it, after you do some practice. So it's okay if you don't fully understand the syntax for now. You can also make a data frame from a dictionary, which I'll just skip over. You can also make a data frame from two series. So here is our first series, right? Because it's a dot series function, we can tell that it's a series. And the second one is your second series. And what you can do, you can use pd.dataframe bracket row 1, comma, row 2 to make a data frame. So this is how you make a data frame using two series. And on to the more useful portion, right? Which is loading data from files, which is what you'll be most commonly doing in like real world applications or like to solve questions. You can also make data frames from reading files. And this is why we have like data sets for you that we wanted to upload, because we'll be using the data sets to perform manipulations on them. So we're using the .read CSV, and CSV for now is kind of like an Excel file, just think of it like that, from this random link, pd.read CSV. And as you can see, it gives us a very nice data frame over here, right, with lots of columns, a lot of rows, and a lot of values. So what if you want to read from an Excel? Well, we can just use pd.read_Excel and just put in your link or your file name there, and it will read it for you. So as you can see here, we have a very nice data frame. So the column names, the index is this one, and the values are the rest. Okay. Oh no, now I need to get values from my data frame to perform operations on them. What will I do? Well, that's what accessing a data frame is for. So bear with me here because it may get kind of confusing. Firstly, we'll focus on the .log function. Ignore the ilog for now. So when you do df.log, put a square bracket, put your row index values, comma, column index values. So what do I mean? When you do df.log, to access a particular value, you can put 0, comma, your column name. So 0, comma, emp ID, and it will return you 21. Okay, that's for .log. So you just put your index name and your column names, row, comma, column. That are the parameters. For ilog, it may get a bit confusing. But for ilog, so as you said just now, you put your row index position. So your row, this is your row index position. This is the 0th row. This is the first row, second, third, and fourth. So you just, if you want to access, let's say, this Python value, you do df.ilog square bracket 4, comma, 1. So instead of using the column names, you'll use the column index position. So this is the 0th column, the first column, the second column, and so on and so forth. So really the most important difference between .log and .ilog is that .log, you can input in strings, not just a number, and you need to input in your index value. But for .ilog, you can only input integers. And now we'll move on to the actual code. So here, yep, it's just what I said just now. And in here, we're going to import a CSV from one of the data sets that we told you to upload into the Colab. So just run it. And yeah, you get a data frame. So what you want to do when you, what would you want to code when you want to extract the value, the row, like the third row? Well, you can do df.log3. And yes, it might get a bit confusing here. So when you just input one parameter inside, it'll return you the row. So, but if you put two parameters inside, it'll be like row, comma, column. And this may get a bit confusing, but just run the code. You can also look at multiple rows at the same time. You just put an extra square bracket around the rows, basically. And see, you get 2 rows. Wow. We'll skip over this, but what you need to know that this is a slicing operator, so you probably haven't learned this before, but it just gives you the 0 to second row. So you see you get like 0, 1, 2. You get from 0 to the second row. Moving on. So if you want to get a column, it's also a bit confusing. So you see .log. If you do .log on a data frame and you only put one value, it'll give you the row. But if you do .log, if you do df and you don't do .log, you just use the square brackets notation. This is how you get a column. Okay? So you just run it and you get a column of GPA. Another way to get a column is using the dot notation. So in here, if I wanted to get a GPA column, I have to use the square brackets, the inverted commas. But you can also use df dot the column name, which is GPA, and then it'll return you the whole column. But note that it cannot be used with column names with spaces. So I advise you guys to just stick to this way of accessing a column. So just use square brackets with the column name, since it's going to be like the easiest one. And another way to access a column is to use .log. And this time you have two parameters, right? You have this is the row and this is a column. And if you put a semicolon in the row, what this means that it gives you all the rows for this column. And then you get all the rows for that column. You can also use .ilog, which just gives you the 0th column. And okay, we'll skip this exercise. If you want to get multiple columns, it's the same as getting multiple rows, right? You just put an additional square bracket and then you put your two column names in here to get multiple columns. So you got the GPA column and you get a comfort food column too. You can always refer back to this part if you forget the exact syntax for getting columns. So it's okay if you don't fully comprehend for now. And this is what you do if you just want to get one value from the data frame. You put in the row index and the column name. So in here you want the row which has index of 110 and the column of comfort food. And then it'll give you the value which is stored there. So this is a very helpful kind of image to represent what you all just learned just now. So data frame, put your data frame name here, .log, put your row index, comma, your column name. Okay, to consolidate your knowledge, now can you get the gender of can you get the entries in the row of gender with the row index of 112 and also 122, 112, and 111. So do this exercise. Use this data frame, so use df. Okay, so 1 minute is over and I really hope that you guys have managed to complete this exercise. So I'll just scroll down to the answer. And yeah, this is how you do the answer. So remember, you put your row here because you want to get the row with index of 112 and 122. And then you put your column name here, which is gender. And because you're accessing multiple rows, you just have to put an additional square bracket around it. And yep, that's how you get this is how you do this exercise. Is everyone okay? If you're confused about something, you can just open a ticket in Discord to ask. All right, so now we're moving on to the next section. Okay, let's say you have a very big data frame and you only want to get the rows which have more than 2000 years. So imagine that years is a column and you want to get the rows only with where the year is more than 2000. So how do you do this? And this is quite important, right? Because in real world data, you need to filter out your data to get the data that you actually need sometimes to perform further analysis. Well, this is what Boolean indexing is for. Okay, so ignore these texts for now. Look at this picture. You have a data frame, right? So the columns are named animals and the columns are named owners. this is the index, and this is the values. So you have a Boolean mask here. And what a Boolean mask is that for each value in this data frame, right, is either true or false. So dog is true, Chris is true. Tiger is false, Bob is false. And for every value here is either true or false in this data frame. So when you add these two things together, you add a data frame and a Boolean mask, you get this result. And surely you must be asking like how, right? Well, if the Boolean mask is true, so dog is true, Chris is true, you keep that row in your final result. And you see Bear and Kevin is both true. So you keep Bear and Kevin in your final result. But Tiger and Bob is false. So just delete it. You don't include it in the final result because it's false. It means that you don't want to include it in your final result. So there's no Tiger and Bob. Moose and Vinod is both true. So that's why you have like result, Moose and Vinod. As for the rest of this is all false, so we like just don't care about the rest of the values. And this is how Boolean masking works. So basically, you filter out rows based on a function. And by that function, you create a Boolean mask. So really what you're doing here is that you're getting a data frame, you're getting a Boolean mask of true or false values, and you compute this Boolean mask using some function created using conditional statements. So, and you get this result. And I'll explain more in the code. Yeah, so this is basically just what I said just now. When you use Boolean masking, only the values in data frame which has true will be extracted into the result. Okay, so this is our data frame. It's just the same data frame as before. Okay, so you want to form a Boolean mask. So remember, a Boolean mask is like either false or true for the values in the data frame. You can form it using a conditional statement. So a conditional statement is statements that contain equivalent to, not equivalent to, greater than, less than, greater than equals or less than and equal to. Or you can use not equals to. So it's okay if you don't know these conditional statements for now. Okay, let's say you'd like to know the list of students, so who are male with like a gender of 1. So to do this, you need to make a Boolean mask which gets only the students who are male, which is gender 1. So how you do this is quite simple. You access your gender row. So remember using the dot notation, data frame dot gender, you get a column row. You get a column. And you check for every value in this column if it's equivalent to 1, which is male. So you get, here's your Boolean mask, right? False means that, the value here was 0. True means that it was 1. And it means that it's 1. So this is how you use conditional statements to get a Boolean mask. Okay, so now you have your Boolean mask, right? So you have like this part. But then how do you like perform this like kind of like addition to get your final result? Well, this is where .log comes in. So you can just use df.log, put a square bracket, and then just put your Boolean mask inside. And after that, it will return only the rows which satisfy the conditions in the Boolean mask. So when you run this line of code, it will only return you the rows which is of male gender. So if you run it, you can see that all the gender here is 1, and which is what we wanted. You can also use .where, but I don't really advise you guys to use it, but you can just read through this. Okay, let's say you want to have like multiple conditions. So it's kind of like an if statement. So let's say you want to filter out the rows. You only want to get the rows with a male gender and with a breakfast equals to 1. So how do you do this? If you want to use an AND operation, you have to use this funny & symbol. So it means that you're considering both these conditions when you're filtering. You only want the respondents who are both male and also have breakfast, right? And you just put it in a square bracket. And something additional this time is that you need to surround each Boolean mask with your round brackets. And then after that, you just use .log to access the respondents who are both male and also have breakfast. And as you can see, the values in these two columns are both 1. It's all 1. And wow, you've just filtered out the respondents. Okay, so this is your next exercise, but there's an errata in here. So can you change respondents with GPA above 3 to respondents who have calories underscore chicken more than 400 and try this exercise? I'll give you guys like 2 minutes to try this out. Okay, now I'll go through the answer for the exercise you just did just now. So it's quite simple. You do df.log, then you put your first condition inside these round brackets, which is you want calories chicken more than 400. And then you put your and, because you want both conditions. And then you put your second condition, which is calories scone less than 400. So sometimes, right, your data set will have a lot of null values or NaN. For example, if you're doing a survey and you're collecting the data, some questions are optional, so your participants just won't fill them up. And then it will have a null value. And in NumPy, in pandas, it's represented as NaN, which is like not a number. So it just means that it's null. So like you see, this is null, so that there's like no value in this particular row and column. So to find the null values, you can use this line of code. Dot is null to make a Boolean mask. Yeah. And to find not null values, just do dot not null. So it's like values where you're filtering out all the NaN values basically. I'll just skip through the exercise because we're running out of time. And next, you want to manipulate data frames. So for example, when you want to update the values or combine two data frames together. This is because data frames are mutable and you can update the values to do various kind of manipulations to them. So to update values is actually quite simple. You access the value and then you put equals and you put a new value here. This is making a data frame. So in here, you can actually update the entire column so it becomes 0. You access the column using .read and you make it all be equal to 0. And you can see everything becomes 0 here. If you don't want it to be all 0, you can also make it so that you can specify the values that you want. So like 10, 13, 20, and 23. Okay, so I'll just run through this very fast. You can combine multiple data frames using concat. So like you want to stack one data frame on top of the other data frame. .concat will make you stack it vertically. So you can see this is your first data frame and this is your second data frame and it just like stacks it on top of each other. So you stack one table on top of the other table using .concat. I'll just skip over this. Okay, what if you want to append one data frame horizontally to another data frame? You can use axis equals to 1 because axis represents the axis which you want them to be appended. And axis equals to 1 represents horizontally. I will also skip through this exercise due to lack of time. This next section is should be quite intuitive. So similar to NumPy arrays, you can do mathematical operations on data frames. So you have to divide this data frame, everything by 2, just do the data frame name divided by 2. And everything is divided by 2. So similarly, you can use exponentiation. And yeah, okay, I'll skip this. Okay, and on to the next part. So this portion is actually quite important and it's quite useful, especially when you're going to like plot your data or do further data analysis. So it's very useful and it's very nice as well. Statistical functions. Okay, .describe function will describe what your data frame is like for you. So instead of like looking through all the data frame values, trying to get a sense of your data, you can just use .describe. For string data, it will return your count, your unit values, your most frequent value, and how frequent it was. So you don't really need to know this, but just know that it shows you an overview of your data. And for numerical data, it shows you like all the important and useful data, like your median, your average, your standard deviation, your mean, and all these like mathematics stuff. These are the other two like important functions. So if you want to see all like the unique values in your column, so let's say your column has a lot of values, but you just want to know what are the unique values in your column, you can use .unique. What if you want to use the unique values? You want to see the unique values and the frequency of each unique value. So like how frequent this value is in your column. Well, you can use your column dot value underscore counts. And this is an extremely useful function that we always use when like trying to plot graphs in like matplotlib and Seaborn, which you'll learn later on. So dot value underscore counts. Yep, so this is the example shown in the slides earlier. And as you can see, when we use .unique, it returns all the unique values. And as you can see, there's like a lot of unique values, and boredom and stress seems to be pretty common in your unique values. To see like the unique values and how often they occur in your data set, as I said before, you can use .value counts. So this is quite useful because like as you can see, right, boredom is the most frequent value. Wow, it's the most common value, and sadness is a second common value. And wow, it's boredom again, boredom, sadness, depression. Yeah, I can see how useful it is when you want to analyze like your data. Okay, so now try to get a summary of this row called calories day in this data frame. Okay, so get the summary of this row column in this data frame called calories day, and also the frequencies of your unique values. So if you want to get a summary, remember you have to use .describe. And for frequency, use your .value counts. And I'll give you like 2 minutes to try this out. Okay, 2 minutes is up. So now I'll be showing you how you should try to do this. Which is here. So to get a summary of the calories day column, you access the calories day column and you do .describe, which is like just describes, just summarizes the data for you. And what you see should be something like this. Yep, you can see all like the mathematical things. And to get the frequency of all the unique values, remember you need to use .value counts. And you should see something like this. Okay, on to the next section. This is the last section of pandas, so try to pay attention, and after that we'll have like a short break. Data cleaning is the process of making data usable for analysis. So as I mentioned just now, real-world data sets with like a lot of things which is wrong with them. For example, missing values which will show as NEN, or like values which is the wrong data type or format. For example, in the data, it should be an integer, but instead it's a string. So you have to convert the data type to your desired data type or format. This is the same data frame that I've been using. And as you can see, right, wow, there's like a lot of missing values. You can see there's like NEN, you can see there's like more NENs, blah, 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 NENs, a lot of NENs everywhere. And this is like very bad when we want to analyze our data, when you want to like plot graphs, because it'll just give you an error when you try to manipulate your data if there are like NENs inside. So what you do is you want to remove a simple way to like deal with your missing values is you just remove all the rows from missing value. And how you do this is so okay, firstly, right, we want to see the column with the most null values. What this does is that this dot is now, it sums all the is nulls in the column, and then it gets the column with the most null values. So don't worry about like the functions in here. First, just know that it gets the column with the most null values in your data frame, and it's actually type sports. Okay, so what we want to do here is that we'll drop rows in the data frame where there's a NaN in type sports. And how you can do this is using the drop NA function. Subset equals to put a column that you want to filter out all the NaNs in here. Axis, just make it 0, and don't worry about these last two parameters for now. But as you can see, after we have dropped all the missing values from type sports, there are no more missing values in type sports. Wow, that's amazing. And I'll skip over this exercise, but you can do it if you want. I'll give you like a short 10-minute break until like 4:20 before starting on the next section. Okay guys, it's 4:20, wow. And now we're moving on to the next section, which is Introduction to Matplotlib and Seaborn. So don't worry, if your brain feels like it's just like gone through a ringer, don't worry, because this will have like less syntax for you to remember, because Matplotlib and Seaborn are like very nice libraries. So hang with me, this is the last section for today. Introduction to Matplotlib and Seaborn. Okay, so Ting Hong will just share the slides for me, and I'll just say, okay, next slide. So Matplotlib is a cross-platform data visualization and graphical plotting library for Python. It's also built onto like NumPy and pandas. So that's why we teach it to you last. So Matplotlib is for plotting funny graphs. So why do we use Matplotlib? It's because it's highly customizable and has a lot of plot styles, which makes analysis easier and much more efficient. Next slide. So here are some like other plotting libraries. We'll be covering Seaborn later. And Seaborn is basically an extended version of Matplotlib for more advanced visualizations and which is more visually appealing. And we also have Plotly, which is another Python library with more interactive plots and is more visually appealing. And we'll not be covering this today. Okay, yeah, next slide. So, but before we plot any plots, we have to understand like certain things about our data. Next slide. Yeah, so there are two data types. There's qualitative or categorical data, and there's quantitative data. Next slide. Okay, so qualitative or categorical data refers to data which has categories or characteristics. For example, types of animals, genres of books, countries, things like these. Okay, all categories. Categorical data can also be numerical, but in this case, the numbers will represent something else. For example, it'll be like 1 for male, 2 for female, but the numbers actually have like another meaning. So that's why it's still categorical. And as for quantitative or numerical data, it refers to characteristics that use numbers or like measurements. For example, your height, your weight, the number of children. So quantitative or numerical data is just data that is measured, that can be measured. Next slide, yep. But within qualitative data or categorical data, there's two types of data. There's like ordinal and nominal data. So ordinal means ordered data, and nominal is unordered data. So for ordinal data, it's things like satisfaction rating. So let's say there's like a satisfaction rating question in a form, and it gives you like 1, 2, 3, 4, 5 stars, with 1 being the least satisfied and 5 being the most satisfied. So in this case, ordinal is ordered data, because if you take away the order, if you like reshuffle the stars, it won't make sense anymore. So that's why it's ordered data. When you take away the meaning, when you take away the order, it won't really make sense. As for nominal data, which is like unordered data, is things like other categories like languages. For example, if you have like English, French, Malay, and then you switch up the order, it'll still make sense. Next slide. Yes, and now on to quantitative data, which is numerical data. And there are actually like two types of numerical data. There's discrete and there's continuous. So discrete data is data that be like counted on your finger, like 1, 2, 3, 4, 5, and it can't take on some values. That's why it's like not continuous on the number line. For example, when you count like number of children, one child, two children, 3 children, 4 children. The number of children can't really be a decimal point. You can't have like 3.5 children or things like that. So that's why it's discrete data. And as for continuous data, it refers to data that can be measured. And that's why it's like continuous on a number line. For example, like height of a person can theoretically range from like 0 to like 200 cm, and it can take on like any decimal between like 0 and 200. And that's why it's like continuous on a number line. Next slide. So to recap, this is like a very helpful image of all the data types. There are two main data types, qualitative and quantitative. So qualitative is categorical data and quantitative is numerical data. Next slide. So why do we have to differentiate data types? Well, it's because we have different ways of dealing or visualizing different data types. Next slide. Yeah, so for qualitative data or categorical data, we have like two ways of visualizing them. Firstly, we'll have our like pie chart, right? We have your pie chart. I think you know what a pie chart is. And then you have your bar chart. So if you go on to the next slide. Yep, so this is a pie chart and this is a donut chart. So I'm sure you all know what a pie chart is. It's a very handy way to represent like the percentages of like the categories. And a donut chart is basically the same thing as a pie chart, but a donut chart has a hole in the middle. So like that's why it's called a donut chart. And the reason why sometimes people use a donut chart is because donut charts are more like aesthetic or more, or you can like nest donut charts. You can nest more charts inside a donut chart. So like you can see the diagram on the right, there's a donut chart and then there's like a mini pie chart inside. And now I'll share screen. Jing Hong can stop sharing, thanks. And I'll move on to the code. My PowerPoint has recovered too, so that's great. All right, so go to your introduction to matplotlib. So how you import matplotlib is you import matplotlib.pyplot as plt, which is where like most of the functions are found. And just skip to this section, plotting qualitative data. So yeah, pie charts. Pie charts are very helpful for showing the relationship of the parts to the whole when there are a small number of categories. So this is how like, your pie chart will look like. And the actual line of, okay, this is the code to make the data to put in the pie chart. And you can see like the actual code for the pie chart is just like one line. So that's a very good reason that why we use matplotlib, because the syntax is much simpler and it's like very easy because as you can see, it's only like one line. You can plot this pie chart using one line. So use plt.py, representing that you want to plot a pie chart, and you throw in your values or your percentages. So your percentages, then you throw in the name of your categories, which is like your fruits. And the rest of the parameters are like kind of irrelevant. You can play around with them. Colors is just the color of your pie chart. And this funny parameter is so that it automatically lists your percentages to 1 dp. You can use .title to show the title of your pie chart. And you can do .show and, well, you get a beautiful pie chart. Just with like this line of code here. And okay, I don't think we have time to do this exercise, so I'll just go through it. We're going to be using this data set, which is like the top 1000 movies by IMDb rating and their respective information. So I'll just go through the answer for this. Okay. So this requires like your use of .value counts, which you already learned in the previous chapter in pandas. So yeah, it's almost the same code except you have to do like some funny things with value counts, which I'll just skip over for now, but you can try it out in your free time. And what you get is this like funky looking pie chart here. But as you can see, right, it doesn't look very nice because there's like so many categories that all of like the tiny categories are like crammed together. Yep, there's like some overlapping text. which is one of the disadvantages of using pie charts, because if there are too many categories, the pie chart will not look nice. And this is where our bar chart comes in. Oh no, I have too many categories to fit in my pie chart. Introducing the bar chart. Okay, a bar chart, I'm sure you've heard of it before. It's used when you want to show a distribution of data points or perform a kind of comparison of values across different categories of your data. And why I use a bar chart is that from it, you can easily see which categories are the highest or most common, and you can compare all the columns against each other. So the actual code for making a bar chart is once again really, really simple. It's just one line of code. And that's why we all love matplotlib. You can just use the .bar function, put in your x-axis and y-axis, and that's it. And this is some additional formatting things. So you run this line of code if you want to label the values on the x-axis, for instance. And this one is for labeling the values on the bar charts. And this is more chart formatting. But what matters is in the end, you get this very nice result. So you can see apples is 35, bananas 25, so on and so forth. And that's why we all love bar charts. So the second exercise is quite similar to the first exercise that I went through. So I'll also just skip to the answers. And you get this very nice result. So this is a nice bar chart. And doesn't this look so much better than this funny scuff pie chart over here? Which is why bar charts are quite good, especially if you have more categories. So that's all for categorical data. Now we'll focus on plotting numerical or quantitative data. And here we're going to learn 3 types of plots: your box plot, your histogram, and your scatter plot. Okay, so this is a box plot. And I don't know if you've seen this before, some of you might have. It's also used in math. So normally it's used to observe the distribution of your data. So if you refer to this right-hand side diagram, this is how a box plot will look like. You have your box, which is why it's called a box plot. And the lower bound will be your lower quartile, your upper bound is your upper quartile. Then this is your upper whisker and your lower whisker, your minimum and maximum value. So it's all right if you don't understand what all of this mean, because it's very mathy stuff. And if you look at this, all you need to know when you look at a box plot is the range is from the start of the box to the end of the box, and the median is in fact this funny orange line over here. So you can see the median of the box plot. And you can see the outliers and the distribution, right? Because all the outliers are these funny dots. So as you can see at the bottoms, there are a few outliers. There are only 2 outliers. Whereas at the top, there's a lot of outliers, very cramped at the top. And that's how we read a box plot. So it's mostly math things. So you don't have to understand this fully. So the code for plotting a box plot is actually really, really simple too. You just use .box plot. You throw your data inside, which we created here. You just throw all the values inside. And then it'll show you a distribution of all the data. You just threw it inside. And you get a very nice box plot, as you can see from here. You can also plot side by plots. For example, if you have multiple values or kind of values, different categories of values, you can plot side by side box plots. And the advantage of this is actually so that you can compare them against each other. So stare at this output. So you can obviously see that you can compare the median, so you can compare the orange line. Which median is the lowest? So obviously it's number 4. You can see that the orange line is the lowest for number 4. And you can see the range, so the length of the box is the biggest on number 4. And you can see that number 4 has generally the biggest spread of data, since the whiskers range from the bottom to the uppermost part of the graph. So that's kind of how you read a box plot. And okay, I will also go through this exercise, but you should do it in your free time. Yep, it's like really simple. It's just one line of code again. If you remember from your pandas, your pandas knowledge, you access the column using the dot notation. This is your data frame name, this is your data frame column, and then you just put it into the box plot function. You output your wonderful box plot. And on to the next way of plotting numerical data is a histogram. So a histogram is commonly used for seeing the frequency distribution of data, often over a time period. So let's start at this diagram. This is a histogram. A histogram looks like a bar chart, I know, but it's not a bar chart. And this is because histogram is used for numerical data, whereas bar chart will be used for categorical data. So they're used for like different data types. And this is something that you should take note of. And the most common use of histograms is to plot data over like years or something. Yep, this is basically what I mentioned. To plot a histogram, just know that it uses this line of code. So it uses the dot hist, which represents histogram function. You throw in your data, and then you can specify the number of bins that you want it to be. So what this means is that how many columns you want it to be here. So like there's 15 columns here that you can split your data into, and that's why you put bins equals to 15. And this is just a formatting parameter. These are just formatting things. And then you get this very nice plot over here. But something is wrong because, you see your bottom x-axis. Why is it all in decimals? It doesn't look very nice, right? And that's why sometimes we want our histogram values to be fixed intervals. And this is what we do. So this line of code is the same, except for one thing, the bins argument. So what you need to know is that you just need to make the bins equivalent to range. Then you put your starting number, which will be like 1920, and then you put comma, you put your ending value, which is going to be your biggest value. And then you put a comma and you put your fixed interval. So in this case, you have like a 10-year interval between each column. So 1930 minus 1920 is like a 10-year interval. And therefore you put 10. The rest is just formatting, and as a result of that code, you just run the code. Yep, you get a very nice histogram. As you can see, it goes from, there's like a fixed interval, so it looks nicer. I will also skip over this exercise because of lack of time, but okay. Now on to the next plotting, which is a scatter plot. I'm sure you have like seen this somewhere before, but a scatter plot is quite useful because it shows you the relationship between two numeric variables. So as you can see, this is a scatter plot of weight of car versus like city miles per gallon. And a scatter plot just visualizes like every single data point as a dot on your graph. So this will be kind of like your physics graphs, the kind that you draw in practicals, but with like more values. Yep, so you can make a very basic scatter plot just by using dot scatter, and you just input your x-axis and your y-axis. And then you can just make a very nice scatter plot. So just like run this. I will also skip over this. We're rushing because there's like less than 20 minutes left, so I'm sorry. So here is like another fun visualization that you can use. It's a word cloud. And I'm sure you've seen this somewhere before. This is a word cloud, right? And it displays the most prominent or frequent words in a body of text. It's a very fun way of visualizing your frequency of your words or ideas. So as you can see from this picture, right, reading is the biggest word. So obviously reading is the most important or the most frequent word in here, and book is also quite big. So to make a word cloud, you need to install a funny package called word cloud. So just like install it, and next you just run this line of code, just like this whole chunk of code, and you get a word cloud. You don't need to understand all of it for now. All you need to know is that this will open this will get your text, and this is the actual code for generating. This is the actual code for generating a word cloud. Yeah, I'll just skip over the specifics, but you can just know this. And you get your word cloud. As you can see, Alice is the most frequent word in Alice in Wonderland. Wow, I wonder why that could be. All right, now it's chapter 3.5. It's Seaborn time. So if you remember from just now, Seaborn is an extended version of matplotlib for more advanced visualizations and is more visually appealing. These are some of the visualizations that we'll be teaching you for today: the regression plot, the pair plot, and the heat map. Okay, so this is a regression plot, and it's actually quite helpful for your visualization. Basically, focus on this picture over here. It will generate a scatter plot, right? You can see like all your dots, which represents a scatter plot, but it will also it will like automatically plot for you a regression line on your scatter plot. So there's like, this is the best fit line, and this is like the worst fitting, the minimum and like the maximum something. And you can also calculate the exact correlation between these two numerical variables using NumPy's core function, and we'll explore how to do so in the code. Yep, so just import Seaborn as SNS. Run this code. Yep, so once again, like the actual code is very simple. It's like one line of code. And the function to take note of here is .regplot. You throw in your y-axis, you throw in your x-axis column, your y-axis column, and this is your data frame that you want to take these columns from. And you get a very nice regression plot of ID versus pulse. As I mentioned just now, that you can calculate the correlation between two variables using the core function, right? And this is how you do it. Once again, it's quite simple. It's just one line of code. You throw in your x-axis values, so like your column, and your y-axis values. And then the correlation here is 0.6790 something something. And how do you read this is actually like, if your coefficient is closer to 1, it means that it has a strong positive correlation. And if it's nearer to -1, it means that it has a strong negative correlation. And as you can see, the correlation is 0.67, which is actually quite close to 1. Hence, as you can see, there's like a positive correlation between pulse and ID. And on to the next plot, which is more complicated. So this diagram on the left is called a pair plot. So you don't need to know like what all the funny subplots in here are for first. Just know that it's helpful for analyzing data frames. And what it does is basically it plots all the columns against all the columns. So when you plot all the columns against all the columns, you can really like see if there's a trend between one column and another column, if there's like a positive trend or like no trend, and it's quite helpful for analyzing data frames. Once again, it's just like one very simple line of code. It's the simplest line of code actually. It's just sns.pairplot, throw your data frame inside, and then you get this. So how you read this is that this is your column and this is your column, and it just plots your gross column against your release year column. So as you can see, there's like kind of a positive trend here, positive trend, negative trend. So this is a very helpful way to visualize your relationships between columns in your data frame. And wow, lastly, before the end, is a heat map. So I'm sure that you guys have like all seen what a heat map is before. Yeah, so basically it showcases relationships between two variables using color. So in here, as you can see from the legend, a darker color means that there's a higher relationship between Brooklyn and 2016. So this is like the most concentrated spot of data in a heat map. Load the data set, and the actual data, the actual line of code is once again really simple. You can just use .heatmap, you throw in your data frame, and then this is like a parameter, and then you get your wonderful heat map. And how you read this heat map is actually so you can see in your legend, the darker ones means that it's like a lower correlation, and the lighter ones means that there's a higher value. So we can see that this cell right here probably has a very low relationship with each other, and this cell right here, which has a value of 98, probably has quite a strong correlation between each other. And wow, we have come to the end of this workshop. You can finally rest your brains. But firstly, we'll do a sort of a recap. So firstly, you learned NumPy, which is about manipulating arrays. And next, you learn about pandas, which is to manipulate data via data frames. Remember, it's kind of like a table. Data frames. And lastly, in matplotlib and Seaborn, you learn to plot cool visualizations. Here are some ending notes. So this is just a introduction to all these things that we covered, and there are a lot of things that we didn't explore, and we really encourage you to explore them if you're interested. We hope that you have taken something away from this workshop, even though it was quite content heavy. So if you didn't manage to catch everything of what we said, we'll be uploading the Google Colab with answers and these slides. And the Google Colab is actually quite comprehensive, and you should look through and try to do all the exercises so you can get a hang of like the knowledge you've just learned. So if you didn't pay much attention during the workshop, which I hope you didn't do, you can look at the Google Colab, and it'll mostly explain everything that you need to know. And you can Google it or ask our facilitators if like any questions. I'd also like to add that the more that you practice, the more that you get the hang of it. So like everything that we just learned seems to be like very content heavy and like impossible to remember or absorb. But the more you do like the exercises or the more you practice, the more you get the hang of it. Thanks for listening, and we hope that you have enjoyed our presentation.